All right, in section 2 of chapter 5, we're going to solve inequalities, this time with multiplication and division. And these are a little harder than the addition and subtraction, but not too bad. So by the end of this lesson, you should be able to do both of those things. Solve these inequalities with multiplication and then with division. So the multiplication property of inequality, there's two things here that we need to look at. And the first one says, if both sides of an inequality that is true are multiplied by a positive number, the resulting inequality is also true. So if you have an example like this, 6 is a number that's greater than 3.5. If I multiply both of them by 2, I still get something that's true. 12 is greater than 7, and it works every single time. So if you have something like 3 is greater than 2, if you multiply them both by any positive number, even 1, you get something that's still true. I could multiply it by absolutely anything here, like 10, and we still get something. 30 is greater than 20. Now with multiplication, if I multiply both sides by a negative number, the direction of the inequality sign is reversed to make the inequality true. So use my example again of 3 and 2. 3 is greater than 2. But if I multiply both of these by negative 10, look what happens. I end up with negative 30 and negative 20. Now, if I put this inequality here the same way that I have it, that says that negative 30 is greater than negative 20, which is not true. So, anytime you multiply by a negative number, you have to flip the sign. And the reason this is because the number line is a mirror image. So you know how it goes up 1, 2, 3, and then on this side it goes 1, 2, 3 the other way because they're negative. So this is a bigger number. The number 30 is a bigger number, but it's not a bigger negative number. And the same rules apply for division. If you multiply both sides, if you divide both sides by a positive number, the inequality stays the same. So if I have 8 is greater than 6, and I divide both of them by 2, I get 4 is greater than 3, which is still true. But now if I take those same numbers and divide by negative 2, I get negative 4 and negative 3. And negative 4 is not greater than negative 3, so I have to flip the sign around. So let's do some solving. We're going to solve these, graph these, and put them in interval notation. So solve, graph, interval notation. So this first one, I have a negative and a 6 hanging out. So what I'm going to do is I'm going to multiply both sides by negative 6. That goes away. Remember, I multiplied by a negative number, so I'm going to change the sign around. So n is greater than or equal to negative 48. And then we can solve. It should be 42. And then we can graph it. So I have negative 42 here. Because it is an equal to, I'm going to close in my circle. And I want all the numbers that are bigger than negative 42. So they're this way. And then in interval notation, I start with negative 42, and I go to positive infinity. Let's try 3a. So 8 and p are multiplying, so to get rid of them, I'm going to divide. I didn't multiply or divide by a negative number, so it's going to stay the same sign. And 58 divided by 8 isn't even, but if we throw it in our calculator, we end up with 7.25. And we can still graph this. We have 0, we have 7.25. And because of the less than sign, I'm going to have an open circle. I'm going to shade everything to the left. And then in interval notation, I start with negative infinity and go to 7.25. It can never equal infinity, and it doesn't equal 7.25. Let's try 3b. So r is a letter we're trying to get by itself. 6 and r are multiplying, so I'm going to divide both sides by 6. So I end up with r is less than negative 7. Now I know it's very tempting here for people to say, oh, there's a negative, I have to change the sign. But remember, the rules say you only change the sign if you multiply or divide by a negative number. And in this case, I'm divided by a positive 6, so that doesn't change it. Now I would rewrite this to say r is less than negative 7, just so that when I graph it, it makes a little more sense in my head. I am going to have an open circle, and I want all the numbers smaller than negative 7. So that's why when I write in interval notation, I'm going to start with negative infinity, because that's what's down here, and I am going to go to negative 7, and it doesn't equal negative 7. Let's try 2b. So for this one, we have a fraction being multiplied by p. We don't usually divide by fractions, so instead what we're going to do is we're going to multiply by the reciprocal, which is negative 3/4. Whatever we do on one side, we got to do to the other. So that crosses all this off, and we just get p. I multiplied by a negative number, so remember to change the sign. And then when we multiply this, we get positive 30 over 4, because remember this is over 1. And then that can be reduced. You can leave it as 15 halves, or you could say that it's the same thing as 7.5 if you really wanted to. Both are the same thing. So we have 0, we got 7.5. I am going to make a nice open circle, and everything less than that is to the left. And then when I put in interval notation, it's going to start at negative infinity and go to 7.5. And since there's an open circle, I'm going to leave a parenthesis there. If you want to try some more on your own, give 3C and 3D a try, and I'll give you the answers in class. But let's do some story problems. So remember these words from before. You can also just stop and think about it. But let's say that this mountain in Malaysia has the greatest concentration of wild orchids on Earth. It contains more than 750 species, or about 1/4 of all orchid species. How many orchid species are there in Malaysia? So we don't know how many orchid species there are in Malaysia. That's what our x equals. 1/4 of them, remember of means multiplication, is the 750. So this right here is something that we can solve. I am going to multiply by the reciprocal, which is 4. And I end up with x equals, oh geez, go back. X equals 750 times 4, which is 3,000. So let's try another one. How many bracelets can Caitlin buy for herself and her friends if she wants to spend no more than $22? So each bracelet costs $4.75. I don't know how many bracelets she's buying, so that'll be our x. So if she buys one of them, it'd be $4.75 times 1. 2 of them, I'd multiply by 2. But no more than 22 means instead of these equal signs here, she wants to spend less than that. She is okay with spending exactly 22, so we're going to put the equal sign on there, and then we can solve this. So we want to divide both sides by 4.75, and when we type that in, we get x is less than or equal to 4.63. Now remember, these are bracelets, so she cannot buy more than this because she'd spend more than $22. So even though 4.63 would usually be rounded up to 5, we're going to round this down. Less than or equal to 4 bracelets. So make sure that your answer makes sense with your problem. And then I have some for you to do. So you have these 4 here, and then you have the other 2 from the other side. Remember to change the sign only if you multiply or divide by a negative number. Write down any questions you have and we can go over them in class tomorrow. Enjoy your night.